Hi everyone, and welcome to my channel. Today, we're going to be talking about an incredible feat of engineering. The Vera Rubin Observatory's 3200 megapixel camera. This camera is no ordinary camera, it's the most powerful camera ever built, and it's set to revolutionize our understanding of the universe. In this video, we'll be diving deep into this amazing camera. We'll explore its capabilities, how it was built, and what scientists hope to achieve with it. We'll also be talking about the Vera Rubin Observatory, where this camera will be housed. So, whether you're a space enthusiast or simply curious about cutting-edge technology, this video is for you. So, buckle up and get ready to explore the universe in unprecedented detail. Now, let's get to the star of the show, the 3200 megapixel camera. This camera is a marvel of engineering, with a sensor that is composed of 8.4 billion pixels. This camera will collect 60 petabytes of data to address some of the most pressing questions about the structure and evolution of the universe and the objects in it. At about 5.5 feet, by 9.8 feet, the 3200 megapixel Legacy Survey of Space and Time camera, LSST, is the size of a small car and weighs around 3,000 kilograms. It will take super sharp pictures of the universe with very few breaks and barely any need for repairs. In this image, you see the robotic arm that automatically switches filters in front of the giant camera. The LSST camera focal plane contains 9 charge-coupled devices, CCDs. Each CCD contains 189 individual sensors bringing 18 megapixels. Sets of 9 CCDs and their supporting electronics will be assembled into square units. The camera's sensors are like super-sensitive light detectors. But they work best when they're really cold, kind of like how ice cream gets super hard in the freezer. So, the scientists put the sensors in a special chamber called a cryostat, which chills them down to a whopping 150 degrees Fahrenheit below zero. This keeps the sensors nice and quiet so they can capture the faintest light from distant objects. The filters on the camera can be swapped in less than 2 minutes. It would take 1,500 high-definition TV screens to display a single image taken by this camera. The detail is incredible. You could see something tiny like a golf ball from a whopping 15 miles away. That's the amazing power of the camera at the Vera Rubin Observatory. This giant camera will capture a massive amount of data, creating a kind of cosmic movie of the southern sky. This movie will contain images of more galaxies than there are people on Earth. It will also track the movement of countless stars, asteroids, and other objects. All this information will be stored in a giant catalog called the LSST, Legacy Survey of Space and Time. This camera would be placed in the Vera Rubin Observatory, formerly known as the Large Synoptic Survey Telescope, LSST, that is a next-generation astronomical observatory currently under construction in Chile. The observatory is named after Vera Rubin, an American astronomer who made pioneering observations of galaxy rotation curves, which provided evidence for dark matter. The Rubin Observatory is a truly international collaboration, with participation from institutions in the United States, Chile, Brazil, and other countries. The observatory's primary mission is to conduct a deep, wide-field optical survey of the southern sky. Rubin Observatory's Legacy Survey of Space and Time or LSST will image the entire visible southern sky every few nights over a 10-year period. It can take a picture of the entire southern sky in just 30 seconds. This rapid imaging speed will allow scientists to track the movement of objects over time, which will be crucial for studying things like dark matter and dark energy. Over the next 10 years, it will take pictures of the whole southern sky, revealing billions of never-before-seen stars and galaxies, that's 20 billion to be exact. Building a camera of this size and complexity was no easy feat. The project took over a decade to complete and involved hundreds of engineers and scientists from around the world. One of the biggest challenges of building the camera was the sensor itself. The sensor is made up of 6 individual detectors, each with its own intricate design and manufacturing process. The Vera Rubin Observatory's 3200 megapixel camera is expected to revolutionize our understanding of the universe. Here are some of the key scientific applications of the camera. Dark matter. Dark matter is a mysterious substance that makes up about 85% of the matter in the universe. We can't see dark matter directly, but we can infer its existence by its gravitational effects on visible matter. The Rubin Observatory will be able to map the distribution of dark matter in the universe with unprecedented precision. Dark energy. Dark energy is another mysterious force that is accelerating the expansion of the universe. Creating an inventory of the solar system, it's like taking a high-resolution panoramic photo of your entire city every few nights. That's essentially what the Rubin Observatory will do for the night sky. It will discover new asteroids and comets. Mapping the Milky Way in unprecedented detail, the Rubin Observatory will embark on a 10-year odyssey to create the most detailed map of the Milky Way ever assembled. Exploring the transient optical sky, this camera will study objects whose brightness or position in the sky changes rapidly over time, often lasting only for a few seconds or minutes. Amazingly, the giant camera is built. But its adventure is just beginning. Next up, it's going to take a very important road trip. They're going to carefully pack it up and drive it way up into the Andes Mountains in Chile. That's a super high climb, almost 3 kilometers up to the Vera Rubin observatory. Once it gets there, they'll settle it into its new home by later this year. Then, the real fun starts, capturing all those amazing space pictures. The camera is expected to snap its first pictures sometime in early 2025. By 2027, amazing photos taken by this powerful camera will be available for everyone to see. That's just a few years away, so get ready to be amazed by what it captures.